Here we have a city math problem. Okay, let's go to the question. In a 3, 4, 5 right triangle, if the length of the hypotenuse is 17, what is the length of the perpendicular line segment drawn from one of the vertices to hypotenuse? Okay, first let me draw a right triangle. Let me do it. Here I have drawn a right triangle. Let me name the vertices. Here we have A, B, C, and we have B at the right angle over here. And this AC represents the hypotenuse of the triangle. And also the question says it's a 3, 4, 5 right triangle. 3, 4, 5 right triangle means that the lengths of the sides of the right triangle are in the ratio 3 to 4 to 5. That is the length of the three sides. To get the length of the three sides from the terms of this ratio, I have to multiply all the terms of the ratio by the same non-zero number, say x. Then 3x is the length of the one of the sides, and 4x is the length of the second side, and 5x is the length of the third side. Usually in these three lengths, 5x is the greatest of all. So it has to be the length of the hypotenuse, because we know that in any right triangle, hypotenuse is the longest side. So this 5x is the length of the hypotenuse. Let me write it over here. And 3x is the length of one of the two remaining legs. Let me take this AB, the length of this side AB as 3x, and the length of this BC as 4x. But we know the hypotenuse of the triangle that is given in the question itself, that is 17. So instead of 5x, we have 17 in our problem. So both 5x and 17 represent the hypotenuse of the triangle. So we can equate them. So now let's solve for x in this equation. For that, we have to divide both sides by 5. When I divide both sides by 5, this 5 will cancel out. Then I'm getting x equals to, when I divide 17 by 5, I'm getting 3.4. Okay, now we can erase this 5x, because instead of 5x, I mean, we know the length of this hypotenuse AC, that is 17. Okay, now to get the length of this side BC, what I have to do is I have to plug in x equals to 3.4 into this 4x. When I plug in x equals to 3.4, then I have to multiply 4 and 3.4. When I multiply them, I am getting, just a moment, 13.6. Now to get the length of this side AB, what we have to do is I have to plug in 3.4 for this x over here. So when I do so, 3 times 3.4 will be, let me write over here, I am getting 10.2. Okay, now I got all the, I got the lengths of all the three sides of this right triangle. Okay, according to the information we have over here, we have to find the length of the perpendicular line segment drawn from one of the vertices to the hypotenuse. We'll be able to draw the perpendicular line segment only from the vertex B to the hypotenuse. Let me draw it. So this is the perpendicular line segment I have drawn from one of the vertices, that is B, to the hypotenuse over here. This is perpendicular line segment. Okay, now let me say this is point D. So clearly this BD is the altitude of the triangle. And also I assume H as the length of this perpendicular line segment drawn from the vertex B to the hypotenuse of the triangle. Okay, now what I'm going to do is I'm going to find the area of this right triangle. So this AB represents the height of the triangle. This BC represents the base of the triangle. Okay, we know the formula to find area of a triangle. Let me write the stuff over here. Area of a triangle ABC equals to 1/2 times base times height. Okay, here 1/2 times the base of the triangle is 13.6 and the height of the triangle is 10.2. So now let me do the calculation. So when I multiply 13.6 and 10.2, I am getting 138.72. That is 138.72 divided by 2. When I divide 138.72 by 2, I am getting, just let me do the calculation, I am getting 69.36. So I got the area of the right triangle, that is 69.36 square units. Okay, now what I'm going to do is I'm going to find the area of the same triangle ABC in the other way, that is using this H as the height of the triangle and this AC as the base of the triangle. Because I use this H as the height of the triangle, the reason is that this is a perpendicular line segment drawn to AC. So now we can consider this, since this is perpendicular to one of the sides, we can consider this BD as height and this AC as a base. Okay, now let me do it. One second. So here, area, let me find the area of triangle ABC again. The same formula again, that is 1/2 times base times height. So here 1/2 times the base of the triangle is AC, which is 17. And the height of the triangle is given by the perpendicular line segment drawn over here, that is H. So we can write 1 times 17H is 17H over 2. Okay, now I got the area of the triangle ABC in two ways. In the first way, I just took this 10.2 as height and this 13.6 as base. Then I got the result 69.36 as the area of the triangle ABC. The second way, I got this perpendicular line segment as height and this AC as base. In that way, I got the area 17h over 2. So both 69.36 and 17h over 2, both of them represent the area of the triangle ABC. Since both of them represent the area of the same triangle, we can equate them. That is 17h over 2 equals to 69.36. Our aim is to find the value of h, which represents the length of the perpendicular line segment drawn from one of the vertices to the hypotenuse. Okay, now to solve for h, I have to get rid of the fraction 17 over 2. For that, I have to multiply both sides by the reciprocal of this fraction 17 over 2, that is 2 over 17. Let me do it. So 2 over 17. So this 2 will cancel out. This 17 will cancel out. Then on the left side, we just get h. On the right side, what we have to do is we have to simplify this expression. That is, we have to multiply that 69.36 by 2, and I'm getting 138.72. When I multiply 69.36 by 2, it has to be divided by 17. When I do so, I'm getting 8.16, that is 8.16. So therefore, the length of the perpendicular line segment drawn from one of the vertices to the hypotenuse is 8.16 units.